Yeah, you haven't added like hot sauces yet.
No, none of that.
You're adding pepper.
You're allowed fruit max, but no more than 2 pieces of fruit. We've got to put some very specific. I mean, my preference would be just don't put anything in it except for Diet Mountain Dew. That would be the preference. But if for some reason you're just incapable of going into the cafeteria to fill a drink without putting something extra in, a piece of fruit would be okay as long as it's like don't put an entire orange in there. Put a little chunk of pineapple or melon or something like that. Those are acceptable things. Not pepper. Pepper is not an acceptable additive to a soda.
I'm glad you specified that the max amount of fruit that you put in there is 2.
Otherwise, I'd get a whole thing of. Huh?
I'm trying to make it healthy.
Well, you're not going to get any healthy. Well, actually, hold on. You can't make diet soda healthy. The only thing we can honestly say about diet soda is it doesn't have calories.
That's true. I try to.
That's really it. I mean, we can't sit here and legitimately say, well, that's not going to cause problems later. I mean, you have something that still tastes like soda. It has a taste, but it has no calories. That's evil. I mean, that's effectively evil, right? Well, aspartame, Splenda, yeah, NutraSweet, and there's one other one, right? Whatever it is. I mean, aren't they kill rats or give cancer to mice or?
According to California, yes.
Yeah, so.
Aspartame literally becomes formaldehyde. Does it? Yes.
You know what Jack told me yesterday?
That doesn't surprise me.
It becomes embalming liquid in your gut.
Oh.
Well, so as I see it, then you're actually saving them some time later on, right?
Exactly. Yeah.
You're saving on your mortuary bills.
Well, you got to leave in your will and testament, make sure they don't overcharge.
Like, no, I already got
Because
enough,
this puppy is par baked.
I've been saturating myself for years with this stuff. I deserve it. A cut of these.
just kick me in the hole and
I'll be fine.
that is an interesting shirt. That is, Mr. Gonzalez wants that shirt. We have to shrink it down.
Well, we'll get a second one for that.
So when my grandpa passed away, it wasn't tragic. He was quite old, right? So when he passed away, and most of you know my family's Jewish, right? And first of all, they bury you about 15 seconds after you die. The Jewish people, they want you in the ground quick. I don't know what the backstory is behind that, but they're not allowed to use a liner for because they want, I guess, the worms and stuff to get in, and so you decompose quickly.
Above the ground, though?
Huh?
Aren't they all above the ground?
No, well, at least my grandpa wasn't.
Okay.
So but you can't have a liner because they want you to decompose quickly or something like that.
The ones that are above the ground.
So this is this really felt like a Jewish funeral, I guess, with this last thing. Deals were going down at this thing on the hood of a car. Okay, so this is right after, my cousin's a rabbi. I mean, my family is super Jewish. Okay, so my cousin's a rabbi, and he did the service, and so afterwards there was a liner. Okay, well, they're not going to pull them back up, right? That's not going to fly. But the liners also cost quite a bit, so they charged him for the liner he didn't want. Okay, so now they're haggling on the hood of this car. It's like, well, somebody's got to pay for this liner. So in the end, I think I think it's the cemetery that puts the liner in there. They ate the cost of the liner, and then they had some guys come in with pickaxes or something to break it up a little bit, so it wasn't so sealed. I mean, this is real sketch. But literally on the hood of the hearse, they're signing the paperwork and getting refunds. 30 yards from where Grandpa's, the guys are shoveling dirt in. I mean, real time.
Wait, hold up. So
It's like, yeah, not even kidding. They told him to stop. We had to break up the. Isn't that messed up? But it actually sort of kind of made the funeral pretty memorable. It's like, that's pretty much what Grandpa would do. He was always looking for a deal. Don't you charge me with that liner. I don't want the liner. You either take it out or you break it, but I'm not paying for it. Ay, ay, ay. All right. That's not us.
Yeah.
Yeah, he listened to the video, I'm guessing.
Of course I did.
Yeah, nobody, I didn't see anybody flame her on Slack.
I've been thinking about it.
Perhaps I didn't give enough pages on the assignment. We need follow
This
through.
time I was actually learning something, so it was fun.
Oh, with the design patterns?
Yeah.
Okay, so interestingly enough, did anybody come up with a particularly, I don't want to go through 50 design patterns, but did somebody come up with what they felt was a particularly interesting design pattern? Go ahead.
I was quite interested by facade that I found.
Okay, so it's that.
With a C.
FACAD.
Face.
Yeah.
That.
And E on the end. Yeah.
That.
E.
Oh, that.
Yeah. Face aid.
Yeah, got it. All right, and what's this guy?
So basically you just create an interface, which you're going to use in your program. And then it will implement, this third-party library, that third-party library, and it allows you to kind of quickly switch between different solutions without really touching your code base.
Because you're using other people's stuff?
Like a
Right.
wrapper.
So like if you, have a website that needs to store data, well, when it's small, you can get away with just a single text document. But when it gets big, you'll have to go over to this giant database. That doesn't make sense when it's small. But with a facade, you can just kind of swap those out without having to adjust your code base. You just need to change the implementation of the interfaces.
Okay. But is the data something that, so usually when I think about design patterns, I usually, you probably noticed, I started off with, it's a good idea to. So what does, is it fair to say that facade is, it's a good idea to create a nimble interface so that when back end or when data sources change, little has to be done or something like that?
Yeah.
I'm wondering what's the real value you found in that?
The wrappers.
Well, I think the main value that I found was that you could easily change out how you're implementing stuff on the back end without needing to go through and do massive changes in your code base.
When you're saying code base, you're talking about your interface?
No, so like.
So what's the difference between back end and code base?
Well, I'm imagining you have your program, and then you have, this thing that your program uses.
The database thing, let's say,
Your
okay.
database, your graphics library,
Mm-hmm,
whatever.
mm-hmm.
Well, normally if that's getting called in 10 different places, change that out, you'd need to go and change that in 10 different places. Whereas with the facade, you only need to change it in the facade. You don't need to go into your program and change that and get all sorts of bugs.
Gotcha. So the facade is your window into a back-end technology,
Right.
and then your 9 or 10 other screens bring the facade into that. So template-y type thing. And so when you change something, worst case, you're changing the facade.
Right.
And then it updates in all 10 places. But best case is if the facade is written in such that it's agnostic to whatever the back end technology is, as long as you don't drastically shift from like, a database to a toaster. You may not need to actually change your facade-based interface. You would just change your code base, your back end stuff that's talking to the database, for example, and the facade would just update, and then all the 10 places that are already using the facade. Okay.
Kind of lets you plug and play
Mhm.
a little bit.
All right. It makes some reasonable sense. Let's do one more. Yeah.
Factory method is what I like.
Factory. Okay. Yep.
And that's where you have like swappable constructors. Instead of using a base constructor from a class, when you create an instance, you have a bunch of subclasses.
Yeah, so you effectively have something that acts as a factory. You ask it for something, it delivers you an instance of that. As opposed to, and usually they're actually not constructors. Usually they're class methods that produce things for you.
Instead of a
Oh, okay, yeah. Yeah, so factory typically says it's a good idea to have, I'm gonna expound on it a little bit, class methods which deliver an instance of a class rather than directly using a constructor. And why is that a good idea? What's the problem with directly using a constructor? Or what might be the problem that factory is fixing for us? As opposed to just saying, we'll get it this way instead of that way.
too generic.
If you're creating instances of your class in 30 different places, this isn't necessarily different to the facade thing, and you change your constructor to take one extra parameter, something like that, right? Now your 30 extra, you got to go and change it in 30 places in your code to make it take that extra parameter. Now, having said that, if the parameter is legitimately an external element that you're going to have to get from the source of it, well, then you're going to have to change your factory method, and they're going to have to pass in a different parameter as well, and you're going to have to call that 30 times. But if your factory method can make the decision of, oh, you just need me to pass you an extra Boolean, let's say, true to do this, false to do this, and then that's fine. The 30 places that are calling your factory method don't need to change. You just change your factory method to call the updated constructor, and now your factory method always says, look, I built you an instance. Don't worry about how I built it. Here's an instance. That's what the factory does for you. Make some sense? So those are interesting ones. Any other extra interesting one?
It was just like a thought, like those two are like commonly used at my work too.
Mm-hmm.
So like for the say thing, so we use it for like website. So let's say you like building like a block of text without like a color, right color, and like right text or like font and stuff like that.
Mm-hmm.
So it's all built, and then we call something like that a wrapper.
Yeah.
So like we can use that to like make the things consistent and stuff like that. While the factory that we use, because we have like 10 applications, so then whenever it's go through the factory, it's actually like launched a website easily, and then you can just change the thing.
Okay, so with that use of factory, you're not necessarily using factory to produce instances. You're using factory as a launcher to launch running applications. And whatever that means to launch that application. If I say start the car, well, we roll back, still some cars like this today, but you roll back 10 years, let's say, you're always putting a key in there and turning the ignition. You roll back 70 years, you might have to get outside the car and start cranking on the front of the car. Today, how many of you have a car that doesn't even have a key? You just have like the thing in your pocket, right? You don't even take it out. Your car just turns on. Huh? Yeah, most of them have the backup. Yeah, most of them have the backup thing. Well, it's like my car just has a fob, I keep the fob in my pocket,
It doesn't even need
and
to
and as long as I'm in proximity to the vehicle, you know, I can unlock the door with my hand. I can get in and just push a button that says start, and it just starts. And then you got those weird ones in the middle where I don't even understand why these exist, where it's like almost like a plastic key, and you put it in, but you don't turn it. You just put it in. Like you couldn't have done the push button thing for me, because now I got to take something out of my pocket. That's just stupid. But the point is that, you know, we have this ability that we want to start a car, right? And starting a car can mean different things, but if we always just call the start car function, the factory method for start car, and it starts the car in whatever way it makes sense to start the car, then you don't have to worry about the different special moves you have to do on your side. So, kind of some interesting stuff. Okay, so let's see. We were slacking, good slack, bad slack.
Oh, that's not from me, it's from the TV. It's from your speaker.
Oh, is it?
Yeah.
Are you lying?
No.
I thought this thing said no distractions.
Apparently that's not a distraction.
Apparently it doesn't. Ooh, what's this do? Ah. I got a. Did I have this new laptop on Monday?
You got a new one? Is that a 17 inch?
I can't read that.
64 gigs of RAM.
Wait, what?
64.
Oh, so no.
Core i9.
Oh, my other one had a Core i9.
Let me know when you get a terabyte of RAM.
Hey, this is the most they'd let me put in it.
That's the Mac Pro.
64 gigabytes.
Okay, we're all drooling here for a sec, so.
Yeah, this is a 16-inch MacBook Pro. So I'm using my other one for a bath mat now. Yeah, that was still an 8-core i9. It only has 32 gigs of RAM though, so I'm bath matting that one.
How thick is it?
Huh?
How thick?
Same as the normal one.
Yeah. It's a Mac.
Can't do that. It's respectable.
Okay, so we've been talking about variable scopes. We've been talking about the, what differentiates an object-oriented language from a procedural language, and hopefully we're starting to see that the answer is not a lot, right? I mean, the goal is whenever we're writing stuff, whenever we're solving problems, any sort of programming language we're going to be designing, and we're kind of pulling stuff together now since we don't have a whole lot of time left in the course to implement new things, but the idea here is that the purpose of a programming language is to allow a human being to solve problems in a way that's similar to the way they already solve problems. That's the goal. Can we come up with something that an object-oriented language, so let's think that this guy is our baseline right now. Now there's different implementations of object-oriented languages, right? So most of us in here, we've been exposed to Java. You've probably seen some C#. How many of you have seen Swift? Okay, we got 1 1/4 people who have seen Swift.
I downloaded the documentation when it came out and then didn't pay attention.
So are all of these object-oriented languages? Yeah, they're all object-oriented languages. Which one's the newest out of those 3? Swift. All right, what did Swift do that enhanced because remember, again, we're saying that the goal of any programming language, not just object-oriented languages, the goal of any programming language is to, let's actually put this on a slide. I'm sure we have it on an earlier slide. Provide a tool that allows a human being to tell a computer what to do while leveraging the way they already solve problems. That's the goal of a programming language. Now, do object-oriented languages do that pretty well? In real life, do we deal with things in terms of objects? If somebody says, pick up your cell phone, you pick up your cell phone, right? This is an object, and this thing can do things, right? So inside of this guy, it has some fields. This guy has an amount of memory. It has a processor. It has, some pieces of information about it. But then it has abilities, things that it can do, and one of those is like make a phone call, right? And it does a zillion other things. Okay, but this is an object. Similarly, this is an object. It's also my lunch. It has fruit in it and stuff like that. So, the point here is we do think about problems in our lives like object-oriented in terms of objects, right? So object-oriented languages make sense. Why did procedural languages ever make sense? If human beings think about things in terms of objects, why did we have languages that didn't do that? Go ahead.
Lack of resources, probably.
Okay, tell me about that. Which resources?
Memory, storage, the computational speeds are way slower.
Okay. Computers couldn't hold as much stuff. They couldn't do things as quickly. Okay, why would that have an impact on the language itself?
With object-oriented,
Go before object-oriented. Why did they make procedural?
oh,
Yeah, you're saying the reason that we made procedural the way we did it, you're saying that we had a limitation of the technology. So I agree with you, but now the question is why? Why did the technology limit us? Why did it force us into that situation? Could we have pulled off object-orientedness with that older stuff?
probably.
Yes.
Yeah, probably, right? I mean, because we've talked about in the last couple of classes this idea that object-orientedness sounds like this complex idea on paper, but it's not. It's just an organizational structure. It's one little container to hold some extra stuff. Go ahead.
I think the reason we started with procedural is because that's what made sense for the kinds of problems we were solving at that point. It wasn't really problems that you would conceive of as a lot of stuff interacting. It was problems where it was like, all right, I'm me, and I need to do these things. I need to add these numbers together. And so I'm just going to follow these steps.
And why were so would you say the problems we were solving back there were simpler problems?
Sequential.
In a way.
Okay. Why were those the problems we were solving?
Well, because that's kind of the selling point that we were selling computers on was, it can make all your math faster.
Okay.
And so everyone was like, oh yeah, we're going to do all our missile calculations with our computers. And so that's just a very...
So really, a couple different reasons. One, so this kind of goes back to what Luke said, is we did have a technology limitation, right? You can only accomplish so much. Now, you can do math really, really quick on a computer day one, right? But some of these other things we rely on computers for today wouldn't have been possible then, right? All right, so we had a technology limitation. But again, I'm going to say, how did that technology limitation drive us? So I think between the two of you, you come up with a very good solution. But let's finish articulating this. It's that the types of problems we solved in the early days of computing were very mathy problems. Fair enough. We can describe the math that we want to do with a computer through would we say that a procedural language is a simpler language from an object-oriented language?
In terms of broad design.
Yeah, so let's think about our language we've been developing most of the semester. If we're going to call that a procedural language, even though we wrote it in terms of a functional language, so we kept it functional so we could use cars and cooters and things like that, we were effectively writing our idea of a procedural language. Was that interpreter really that complex? I mean, it had its moments, right? But generally speaking, we just kept adding little abilities to it, didn't we?
Yeah.
So really a procedural language can start off pretty simple. And if we have a language specifically for telling the computer to do math, can that even be simpler? Go ahead.
I was going to say, it seems simpler, the procedural language, because it's doing like what you need it to do and only what you need it to do. But wouldn't a object-oriented language be like more abstract in the respect that like you have something very generic that can be turned into something much more complex?
Okay, so more abstract in a good way?
Yeah.
Like, why didn't they still do it?
Right.
Okay. It's a good question. Well, you have a stab at it, and then I'll give you my take.
Just allows you to have the one-to-one relationship easily instead of like with interpreters. That's CPU level machine code.
Okay.
If you had objects at that level, it would be more complex calculation.
Okay, so you're saying that maybe the compiler to process a procedural language might be a little simpler than the compiler to process a object-oriented language. I mean, maybe marginally, but there's probably some truth in that. You have to, as your aim. The question is it because it's object-oriented, or is it because the language is more feature-rich? It could be a coin flip at that point. I mean, I think compilers become more and more complex as your processors learn how to do more and more things, as you have more magic tricks on your CPU, and your language lets you get at those magic tricks in more powerful ways. Then all of a sudden, I mean, we take for granted what the compiler is doing for us, right? It's sitting there in the middle, and we're happily writing our Java, C#, Swift code, whatever, and then we hit the little play button, and behind the scenes, a compilation is happening, and it's translating all of our beautiful code into zeros and ones. Low-level language first, assembly for Intel, whatever, and then ultimately to zeros and ones. But, it's doing that for us, and we basically show it no respect, right? Oh, just run it through the compiler. That guy's doing legit stuff. Not only is it giving you from your starting point, an accurate representation of that. One of the jobs of a compiler is also to make a mediocre programmer look like a good programmer at the low-level language level. So, look, you write crappy but correct high-level code, we will turn it into at least as efficient, if not more efficient, low-level code. That still works, something like that. So the problem the compiler is solving is a pretty difficult problem. So it would be, I think, fairly hard to really measure whether compilers for procedural languages would be more or less complex than compilers for an object-oriented language. I think the truth would be they would almost always be less complex, but is that because we're doing less with the procedural language than we are with the object-oriented language? I don't know if it's because of the object-orientedness of the language as opposed to more of the underlying rationale that I'll share with you in a second. Any other takes? Go ahead.
We weren't thinking about we weren't thinking about the last bit of how we're defining a programming language's goal right now. What were we not thinking about? Like originally, we weren't trying to do the things the way humans do them necessarily.
Okay, why not?
It was a new thing, we hadn't thought of that.
Okay. Yeah. I mean, I think
things that's easiest for the machine because that's how we're working with it right now.
Yeah. I mean, so I think we really have this thing pretty surrounded. And this kind of goes back to something you've heard me say, I think, fairly often recently, not necessarily related to this class, but I say it in most of my classes. You've heard me refer to our toolbox and stuff like that, right? And I've been talking a lot about it with the 3D printing stuff, is that, as human beings, we solve problems in terms of the tools we have available to us, right? And we can only solve problems as complex as our understanding of those tools. So the first time you see a computer that's getting thrown in front of you, you don't know what that thing does. And if you spend a week with a computer, do you know everything that computer can do? Or do you just have a taste of what you might be able to use that tool for? So we think about the early days of computing. Programming languages were allowing us to tell a computer what to do, and the types of things we wanted to tell a computer to do weren't necessarily all that interesting. We hadn't started dreaming yet of what a computer could do. How can we push this farther, push this a little farther? That's what humans do, right? We're never happy, right? You have 20 megabit per second internet, great. That used to be a dream when we had 1.5 megabit per second. Now, I'm not even going to connect that to my toaster. I can't run my toaster over Wi-Fi on 20 megabits. Come on. I have one of those cycling Yoda toaster patterns where every single day I get a new Yoda. You guys haven't heard of that? Huh?
Baby Yoda?
Yeah, Baby Yoda is awesome. I mean, have you guys seen Mandalorian?
I need to.
Man.
Not yet, no. Yeah.
I'm still waiting for someone to come out with a toaster that will print tweets on it.
That would actually be pretty funny.
Yeah, but it was only one face. You would send your face to them, and they would give you a toaster. That would only ever make.
The question is, like with this Mandalorian thing, I won't give anything away, but does it make us feel dumber as a society? Because think how we've been taken advantage of. So first we have like the Marvel Universe with Guardians of the Galaxy. The only reason Volume 2 was so good was Baby Groot, right? Now, we like Baby Groot, but the question is why? Did they take advantage of us? They just put this cute thing on the screen doing this crazy stuff, and now we just fall in love with it. I mean, that's like insulting to our intelligence. They could have done anything with that movie, right? And all they had to do was put him on the screen plenty, and we wouldn't have complained. Same thing's true with Mandalorian. It doesn't matter how bad that storyline might get. I mean, I think so far it's been all right, but I can't even honestly, unbiasedly tell you. The storyline might actually suck. But they just put this Baby Yoda guy in the show, and now you just don't even care. You know, we're all hopped up that he's got this scene where he's sitting there sipping soup. He's sipping soup. What other time would you get so excited that a 50-year-old was sitting there sipping soup? But there's memes all over the place with Baby Yoda sipping soup, and they're excited. People are complaining online that you can't buy Baby Yoda merchandise.
Yes.
They got us wrapped around their finger. It's insulting, isn't it? We keep coming back for more. That's what we've fallen to as a society. Okay? Christian worldview here, we are in a fallen society, and this is how bad it's gotten. We will buy anything if Baby Yoda's on it or Baby Groot's on it. That's why Volume 3 wasn't as good. Teenage Groot? We don't like Teenage Groot. All they could do is put some comic relief in there with, everybody seems to speak the Groot language, right? You know, where he says, I am Groot. And you're like, language, hey. Nobody knows what he's saying, but we find it a little bit funny that he might be swearing. No, we need him to die again so he comes back as another Baby Groot. This whole Teenage Groot's not working for us. I think we can agree that I'm right.
Get on the recording.
What's this?
How deep into conspiracy theories are we allowed to get on the recording?
Ooh, I don't know. Depends what direction this starts going. And I'm a little nervous.
Just trying to get the Star Wars and Marvel.
A mashup. All right. So, we always solve problems in terms of the tools that we have available and also in terms of our understanding of those tools. So in the early days of computing, we did have technology limitations. You're right. We did have specific types of problems that we definitely wanted to solve with our computers. These mathy problems and stuff like that. If you guys have seen the Hidden Figures movie, that's a good example. I mean, that movie's shown pretty often for, women in science and math and working at NASA. So it's interesting for all these other reasons, right? But then the reason of, hey, we used to do that math by hand, and whenever, you had these, people in space that were relying on your calculation being accurate in real time, and, I don't know if you know this, but sometimes things go unexpected when you're in space. Right? And you zig when you're supposed to zag, and all of a sudden now the math changes. And you might miss the moon. Okay. You're missing, the moon's a big thing, right? But when you're that far away from something, and something changes by just a skosh, you might miss the moon. Or, coming back, right? You might hit the atmosphere at the wrong angle, and you bounce off. You should only be so lucky that you bounce off. Right? At least then you maybe have a second shot, right? Hopefully you figure it out. Otherwise, you come in at the wrong angle, you burn up.
Or you
You're really, really, really relying on that math.
Collide with a paint chip and spaceship blows up.
Yeah. So we're relying on that math, and we used to do this math with these brilliant human beings that would pump this stuff out by hand. And what that show really emphasized for us is it doesn't matter how fast a human being can do the math or how gifted that human being is at math, a computer can do it faster. Right? That was the point. So we no longer needed the mathematicians, no matter how gifted they were. So now what did mathematicians do? They had to repurpose themselves to now put themselves behind the computing power, which actually has really pushed technology, right? So much of our technology is based on fast math. We still need the mathematicians. They need to come up with the fancy schmancy math algorithms for doing things. We'll just plug it into the computer so it does it really fast. Make sense? So all these things are part of where we got to with technology, but we always solve problems in terms of how well we can wield the tool and how fast we can wield it. Computers can wield things fast. And, fine, they kept getting faster and faster and faster and faster. Just a few minutes ago, I popped up the specs on this laptop, and it looks all fancy that it has an 8-core i9, whatever. How often am I using that? I mean, the times I'm using those system resources, basically I am never using all those system resources when I'm running a single operating system.
Can it run Crisis?
Well, I'm guessing probably. It's got a solid GPU. Does it run on Mac? Then no. Although maybe, because I use Parallel. So really I use my system resources when I'm running. I might be running Windows, I might be running a Linux at the same time. I just run them on separate windows. I have plenty of system resources to share across those. Well, Parallels uses Apple's Metal framework, which will let you go right down to the hardware. So as long as I run Parallels in full screen, I can install Crisis on Windows and presumably play it. But Crisis isn't even it doesn't push your stuff anymore. Isn't Crisis like 8 years ago?
Still looks really good
Huh?
Still looks
Oh, does it? That'll be an interesting experiment. We should do that. We should take some high performance game that's for Windows only, run it on Parallels, and put it on because this has 8 gigs of RAM, GPU RAM. I have as much GPU RAM as some of you have RAM. I have more GPU RAM than some of you have RAM.
Bear some RAM, please. Bear some RAM for the poor.
Spell Rob.
Yeah, this had 8, right?
Oh, so you're lock clear now.
Yeah, this is a Radeon Pro 5500M with 8 gigs.
Yes.
Yeah, it should be fine. That'd be really interesting. It's like some game that won't run on your gaming machine and run it on this through a virtual machine. It's like, what do you get? I'm getting 300 frames per second. It's the limitation of the screen. It's Apple's True Tone display. It just dumbs it down. I can't exceed 300 frames per second. Well, what about your eyes? Yeah, I'm having those upgraded. It's fine.
I've done Minecraft with 2 mods.
Yeah, I've got 15 different things with 3
All right. So as we have evolved our mentality of what we can do with our computers, have we then also evolved our mentality of what we need the languages to do for us and how we're going to leverage those languages? Procedural languages, if we just dumb it down, isn't it just a list of instructions? Do this, then this, then this, then this, right? When we started hitting the limitations of procedural languages is as we started relying on computers to do more and more stuff, right? And we had to then evolve our problem solving with those procedural languages until we started, kind of bumping up against the constraints of the languages. And this really came through structs, right? With structs in the C language, we started wanting to represent objects. Before we called them objects, we wanted to represent the idea of objects in terms of their fields. It all says like, oh, well, I really want this struct to also be able to call some functions. Well, now it's what we today would call a class. Back then it wasn't. We didn't have those. Structs couldn't do functions. So we started looking for hacks, right? So we had like void pointer functions where we actually stored our function in a memory address and had it call, like you hacked the system to effectively be able to hide a function inside of a struct as if it was a variable. So at some point you need to say, I need a better tool. This tool, I'm starting to stretch the tool. Why do we still use C today sometimes? Okay, so if we're saying that have we grown out of procedural languages? Let's take it from the perspective of the types of problems we know we can solve with computers, and now the imagination of the human being, and given the fact that we already solve problems in terms of objects in real life, have we grown out of starting brand new projects today with a procedural language?
Most people think they have.
Probably. We probably have. Because now we have to almost dumb ourselves down to think procedurally. When you're writing procedural code, you feel more like a coder. You feel more abnormal compared to normal society, right? Object-oriented code makes us feel a little bit more human because we're still thinking humanish. Make sense? Even though there's still code there and other people are impressed and things like that, we're still able to think through our problems as if it's kind of real life objects and stuff like that. So why are procedural languages like C still used?
They're tiny. You make a C compiler that's just a couple hundred bytes.
Okay. Tell me more about that. Do we necessarily care about the space now? We got tons of memory. I got 64 gigs of RAM.
No, but when you have to have this tiny little thing that sits on your lapel and is supposed to kind of tell you the time of day at any time.
Yeah, we don't need the compiler for that though. We just need a binary. And we can do the compiler on the giant computer, and it writes it down to the binary, and the binary runs on the hardware on the machine. It's compiled for your microprocessor that's on that super low powered device, whatever that's on your lapel. Yeah.
The example of like the robotic arm in the makerspace.
Mm-hmm.
That's procedural language.
Effectively, yes, and because it's a CAD-based language, so it says do this, do this, do this, do this, do this, and in a sequence over for a long time. Go ahead.
I mean, part of the reason that we use C is also for operating systems when we need to have it as small as possible and as memory efficient as possible. So with most of like the more object-oriented programming, at least the modern ones, do sort of like automatic garbage collecting and allocating. But this way you can allocate specific amounts a little bit.
Okay, but you can turn off those special features. My car has the autopilot thing on the interstate, but if I don't want to use that, I can turn it off. Not the end of the world. But C is still used sometimes. It is falling out of favor now. We're starting to see the transition. But so it's probably relatively uncommon today for us to have a brand new project starting in C. Now, but the rationale for that, and Appel's kind of hit on this a little bit, is the things that we might run a C program on. And this is also becoming a little bit of a different thing as technology gets smaller and cheaper and more memory and things like that. But we might have little microcontrollers that are running our dishwashers or something like that, right? And that's a special CPU. That's not made by Intel. That's not made by whoever. It's Bob's CPU from some factory, and it has these 30 magic tricks that it knows how to do. And it just so happens that there is a C compiler that will compile for that architecture. Right? So Which do you think is a more evolved compiler, the C compiler or the Java compiler? Or the Swift compiler?
Java compiler does more work.
Well, it does more work, but which one's been around longer?
C compilers.
C compiler. Do you think it's probably gone through a couple of iterations? Remember we talked earlier today about the job of a compiler is to make a mediocre programmer look like a good programmer at the low level? Do you think we've gone through lots and lots and lots of iterations in that C compiler where it can turn pretty crappy correct code into faster than it should be low level code? So typically we have more architecture supported by our C compilers because we've kind of viewed them as special purpose now. But historically, our operating systems have been written in C. So any maintenance we're doing on them, let's not write a whole new operating system. Let's just keep working with the operating system that we already have. And our core operating system, for instance, Mac, this isn't Apple's stuff. This is running on top of BSD Unix, which is written in C, right? University of Berkeley. So I mean, this is this old operating system. It's gone through the wars and it just works. Most of the bugs we run into, Apple added. It was okay because we want those features, right? Okay, so we want to think about C as an important language that is losing favor. So having said that, for Friday, and we'll talk about the exam on Friday, I want to, similar to what we did today, three-page paper discussing the use of C today compared to other languages. Will C still be used in 10 years? Why or why not? And for what purposes? Make sense? This isn't a punishment paper. This is a very interesting thing because we really want to kind of wrap up the semester with this concept leaving here that a programming language is a programming language. Object-orientedness isn't all that fancy, right? We've seen that it's a fairly simple concept. So how do we see our languages really changing in the next 10 years? We'll talk a little bit next class, I'll have a slide for it, about what's changed in Swift and how some of these changes have started becoming pretty almost laughable, trivially laughable type of changes, and then ask the question of what's next.
Emojis for variable.
Emoji variable names.
Oh, that's terrible.
No, that's in.
It's true.
That's actually, I know it is.
Swift supports emoji variables.
That's terrible.
All right, I'll see everybody on Friday.